j, and k. I, you want to put the rest of it, fine. You don't want to put the rest of it, that's fine too. Plus 0 j, 0 plus 0 k. Is that correct or not? That is the case. Many people, couple of people even didn't write it there because they couldn't figure out what is the tension in the cable, which is on the x-axis. I don't understand. Because the other one is much more difficult apparently. This is on the x-axis in one dimension. Anyhow, I'll explain that. Then it comes to W. Of course, you write the W as well. Some of you didn't, but that's okay. 0I minus 300. The magnitude is given, goes downward. J plus 0K. Obviously, you have to put here near term and near term. You put in front of every number. Some of you are more specific. And then come to TAC. TAC. Now, some of you still writing 2, 3, 4, 5, 9. I said it's not required. TAC is equal to its magnitude. Is that correct or not? Times the lambda. You can write it in 1 line, 2 line, or lambda AC, or equal to TAC magnitude, which is not given, multiplied by coordinate of C minus coordinate of A, which many of you did it correctly. So it becomes minus 6, 3, and 2, and the vector become meter, and this is meter, divided by its magnitude, which becomes 7 meters. This is square, this is square. And we're going to have to expand it. This is good. So why do you go expand it and make it into a decimal point? I don't know. 6 over 7 is as good as 0.853. Is that correct or not? So it is. Just sit there right there. That's it. X component, Y component, and the Z component. That's all you have to write. You don't need anything else. And finally, TAB, which is equal to, again, its magnitude times a unit vector, nothing. These are magnitude, these are vector, and many of you do not follow that. Lambda is a vector. Why? Because it has ij and k. Lambda is cosine theta I, cosine theta yj, and cosine theta gk. Is that correct or not? Yes? Anyhow, again, the same format. You use TAB, magnitude, times, again, coordinate of D minus coordinate of A, which this time it's very simple, minus 6, 2, and minus 3, meter over meter, and we leave it at that. This was really what I asked you to do. Of course, the idea is this, that summation of all these forces together must be equal to 0, and then TAB plus W in vector form plus TAC plus TAB as a vector. This becomes a polygon of the forces, and that is equal to 0, and 0 should also be as a vector. That's why you get to sigma fx equal to 0, sigma fy, and sigma z. Now, since this is the key, and these are the forces, all the x component must be equal to 0. But then some of you are still using jumbo mambo and doing this and doing that. You have the idea that all the x components should be equal to 0. So why don't you write it the way we want you to write it? When you give this to somebody who can read it, what you are doing it. Everybody understand that the idea is there. Your performance or your presentation is not good sometimes. Is that correct or not? Some people write I, some people write that. That's not the case. We have three scalar independent equation from each other. One of them is sigma fx. By the way, sigma fx, some of you writing fx equal to 0. There is a big difference between these two. Everybody understand what I'm saying? And some of you laughing, and some of you doing it. At least 10 people write it like that. You one of them, yes? Okay, well, you understand what's the difference between sigma fx and fx? Sigma fx is actually the sentence. Summation of the forces about x-axis must be equal to 0. Fx is the x component of a force. One force. Is that correct or not? One of them. So that's a big difference between the two. But if you don't write it, you should follow. And if you know it, why don't you do it correctly? Some people put ijk, which is the same thing. You are summing up all the forces in the I direction. That's a little bit better. But still, these are three scalar equations. It's not a vector equation. And that means this. That means from the first one, magnitude of TAB, whatever that is, plus second one is 0, from the third one, which is minus 6/7 of TAC, and from the last one, minus 6/7 of TAE. Together, whatever their number is, must be equal to 0. That's one equation, but it has 3 unknown in it. Is that correct or not? Yes? Is that correct? Did I did it correctly? 1, 2, and 3. Correct. Yes? Then you come to the second equation. Second equation is sigma Fy. You can write it like that, a little bit shorter. Sigma Fy should be equal to 0. But from the first one, we get 0. For the second one, we get minus 300, and then we get plus 3/7 of TAC, and from the last one we get minus 3/7 of TAD equal to 0, 1 by that. Is that correct? And so on and so forth. And then finally sigma FC, which is from the first one is 0, from the second one is 0, from the last one is 2/7 of TAC minus, oh, this is a mistake, isn't it? That should be 2. That should be 2, and this should be 3. That's correct. 3 minus 3 over, and that should be plus. Let me see. Plus 3/7 of TAC plus 2/7 of TAD, that's the y component. So if I make a mistake, please point out that. Okay? Correct? Okay. Then from the last one, we get 2/7 of TAC minus 3/7 of TAE equal to 0. I did ask you to solve it because you were short of time a little bit, so I gave you some sort of leeway there for you not to fail. But of course, as you see, it's very simple. This was for the quiz. Look from the last one. If you write it like that, this 7 and 7 drops out. Yes, yes, sir. So first of all, some of you came to this conclusion. TAD came negative. Can TAD become negative or TAC become negative? Tension in a cable never is negative because that's not a rod. The rod can take tension or compression, or the spring you can put it or you can push it. Everybody, but here is a tension in the cable always should be positive when you get the answer the way you draw the free body diagram. Nevertheless, from the last equation, as you see, so TAC become equal to, TAC become equal to, if you want to solve it, this goes to the other side, 7 and 7 drops out. TAC become 3/2 of TAE. As simple as that, or 1.5 that. Then you plug it in this one, you calculate TAD and TAC, you need about 2, 3, 4 more minutes. Everybody understand that? Yes, it was not as difficult as some of your homework assignments. Correct? Because this was a quiz, but still you didn't have to do it. So pick up that, you put it here, you calculate for TAD or TAC, you plug it here, okay, and then you calculate. Anyhow, the answer, if you want the answer are the following. So TAD magnitude become 323 Newton. TAC magnitude become equal to 485 Newton, and TAD, which is the tension in the spring. I'm a little bit surprised about TAD because the one I did one in class and it was exactly like that, but instead of x-axis, it was on the z-axis. Remember? Yes? Okay. All right. Thank you. Anyhow, any question? Not about the quiz, but that's clear, because I have enough notes on your quizzes that you can do what you did right and what you did wrong. Is that correct or not? But average was much better, so average was about 14. Should bring some smart here. Yes or no? It was not like the first one, it's a little bit better. It's intended that way, I told you, but now things get a little bit more interesting, not more difficult, more interesting from now on, which is we're going. Is there any question about your homework? Because some of the homework I have not done it yet, so let's go forward. That if you need to ask any questions, please do. But let's go back to the problem that we already did last time. I put the result on the board, and because I need a few more discussion there. First of all, there was a tree or a dead tree on the y-axis, and we had here x, y, and zx. Then there were a cable going this way and a cable going that way. I believe this one was B8, and the other one, because we see what we did last time, we found that the forces at point B on the tree, and we found the resultant, then we found the moment of that resultant about point O, yes or no. And then we found the magnitude of that, etc., etc. And then at the end, when we end up MO, or MO, for last discussion, let's put it here, MO as a vector, because now moment also is a vector, especially when you are dealing in 3D, you get the vector. In 2D, when you use some of your homework, when you use force distance method, you only get the magnitude. The direction of it comes with right-hand rule. As I said, if the two vectors are in this plane, this is plane of x, y as usual. This is x, this is y. If F is here, R is here, F is here, perpendicular to the plane will be plus K or minus K. However, this is typical of what we do, but that's not necessarily always true. If you are working in this plane, which is plane of Z and Y, perpendicular to that one, become I. But that's a 2D plane. Is that correct? But this is a 2D plane. This is a 2D plane. You are drilling down, you are creating a moment. The axis of that moment is in the Z direction, perpendicular to that plane. Everybody understand that? However, it is one-dimensional. It means it has only one component, either and on. Usually, when we do our plate or our notebook in front of us, we call it X and Y, yes or no? So most of the time, we get our moment about the Z direction, correct? Because I can call that plane X and Y as well. Is that correct or not? Yes? How? In 3D, that's different. In 3D, this end up, I forgot how much was it. It was 3080i, is that something like that? Yes? I can look it up. So please look up in your note, because I want you to refresh your memory what we did last time, because I want to continue with the discussion. Okay, so we got that one, and then we had no moment about the y-axis, and I gave you the reason, and then we have a negative 2070 K, and the unit was meter. We calculate the magnitude of that, etc., etc. Now this continues with discussion. There are a few more points that some of you already answered. I noticed as you came to my office, and these are all being understood. The force was here. The force, because we cut it here again. We cut it there. The forces at B are different from forces at A and C. We have discussed that many times. So this was the force tension BA, which we said last time we calculated, and this was tension BC. We calculate that one. Now suddenly somebody asked, for whatever reason, what's the angle between this cable and that cable? Can I calculate that?
Yeah.
Yes, that means you have done your homework. Correct. Yes, some of you shaking, some of you not shaking your head. So I want to see more head going like this. Is that correct or not? Yes? All of you know how to do it? Okay, no? All right. That's why I'm explaining that. So that was a dot product, yes or no? Cosine theta was what? Please, this is the question, and this is the answer. The question is, what is the angle between these two cables? If I need to calculate that theta, how do I do that? You have many choices here. As lambda, not lambda, theta. The angle between two cables. Oh, you are using the lambda. Oh, I see. Yeah. Yes, we can use the lambda, correct. But let's, before that, do we have TA, DA? Do we have two TBC? Can I use this too as my two vector? Because all I need, remember, cosine theta, go back to your note, was equal to what? Was dot product of A dot product B divided by A magnitude and B magnitude. The result is this. This is what it should You should remember. The result you need, that's what you are giving me the answer. You are ahead of it. I mean, a little bit ahead of me. All I need two vectors, one along the one cable, one along the other cable. Yes or no? A and B intersecting at point B, and that's exactly where they were. This was A, and this was B. Remember that? So what's the difference? Doesn't matter. Do I have this scenario there? Yes, I have. Yes or no? And that's the angle. That was the theta, correct? But I can use this. Cosine theta is equal to T BA as a vector, dot product that with T BC as a vector, divided by their magnitude. One was, I believe, 500. One was 555, correct? Yes. Yes, 555 multiplied by 660 Newton. That gives you the theta. Is that correct or not? Now, the suggestion, good suggestion there came from there. I am only bound to use that? I can use this. I can use RBC divided by, dot product of RBA. You have that in your note, isn't it? So all of these are acceptable. Please write it down. RBA, which is a position vector, dot product of RBC divided by RBA multiplied in magnitude of RBC. That also gives me data. A better suggestion, can I use lambda? Because you already calculate the lambda of line 1 and line 2. Are you with me? Yes? More or less? Come on. It's okay. I told you, I'm going to look into your eyes to see what you are doing, every one of you. So you cannot escape that. That's all right. And then I can write also cosine theta equal to lambda of BC dot product of lambda BA divided by 1 and 1, because the unit vector, which is simpler. You already have two lambda. You have all of them in your note. If you go back again to the previous lecture, you have all of them in your note. Correct or not? So what I'm saying, or you can use combination. In future, whatever you have, doesn't have to be any specific, for as long as you can use combination of TBC and unit vector here. It has to be two vectors, one on line 1, one on line 2, and that will do it for you. Any combination, so you have all sorts of. But you better be consistent, use the same thing. Is that correct? Yes?
Shouldn't it be lambda BA dot B?
Lambda from, no, lambda BC and lambda BA. That's what I saw, yes. The order doesn't matter. Are you talking about the order?
Yeah.
No, the order in dot product doesn't matter.
Okay.
Remember, A dot product B is the same as.
Well, you use the same theta, but it's in the, when you're doing right hand rolls in a different direction.
No, actually that's for the cross product. Cross product make a difference. Dot product is the same. We discussed that. A dot product B is equal to B dot product A. Is that correct or not? So either way you can write it correct. That's the question I answered before. Correct? Okay. All right. Yes. As you see, everything that is said, that's one aspect. So we talk about it. Many of you already knew that. This is total moment. I believe the magnitude of the moment MO, we found it to be 3,710. Did you give it to me? If I didn't, did you give me that? 710? Yeah. 710 Newton. I need that for the next question. The next question is this. What is the shortest distance from point? Please write down in your note. What's the shortest distance from point O to the line of AB? You must write this in your note, otherwise the solution doesn't mean it. The first question, we already answered. This was just a review of what I said before. I told you before, I will always do an example of two, then you do a few homework, then it comes in the quiz, everybody will be happy and smart. Yes or no? Hopefully. Okay. Therefore, what's the shortest distance from point O to the line of AB, to the cable? Let's say somebody wants to build this and for some reason needed the shortest distance from here to here is a line perpendicular to AB. Is that correct or not? Which is geometrically very difficult to calculate. It's not a 2D. In 2D, somehow I can manage that. In 3D, it's impossible. Yes or no? So how do we do that? What? FD, that's right. Because M equal to FD, that's what I hear. M equal to FD. So if I calculate moment, and like what I did here, but can I use this moment? Because I have given this problem to a student, many I would say this is moment, and then moment equal to FD, that's D. Is that correct or not?
The magnitude?
No. If I do that, this is the magnitude of the moment of both this and this about point O. Everybody understand that? If you use that, you are finding the shortest distance from point O to the resultant. Everybody understand what I'm saying then? This is not the question. If I ask you, find the shortest distance, because the resultant is somewhere here in here, yes or no? Remember, this is what we did last time. If somebody asks you find the shortest distance from point O to that resultant, I can use this moment. Is that correct? And that moment equal to FD. But what was that moment? How did we calculate that? That was the moment of the both forces about point O, yes or no? But my question wasn't that, so please be careful. That's how I want to see whether you understand this completely or you sort of shortcutting it. I'm asking you to calculate the moment at the shortest distance from point O to the cable AB only, yes? In that case, as if this doesn't exist, I don't care about that. So what do I need then? What's your answer now? Look, the moment of that force, TBA, about point O. Let's do it then. So calculating that, which is different, that's why sometimes some people prefer to do that individually rather than resultant. So I need now this time MO equal to ROV cross product of TBA only, because I'm only interested of moment of that, and then your solution will be correct, because the moment, the magnitude of the moment equal to FD, yes or no? Correct? Then I find the shortest distance. So we do it in reverse. First, we calculate the moment of this force about point O by using the standard cross product method, which is, we have done this last time. Remember last time we did it. I put here IJK, but last time this was not TBA. That was the resultant of two forces. Yes or no? Correct or not? Yes? Therefore, hold on. I'm trying to find out only this is the D, perpendicular to this line only. Therefore, I'm taking the moment of the TBA about point O, which gives me a position vector OB cross product T, which is the definition of the moment. OB is 0, 7, 0. Is that correct or not? 0. And TBA, what was the TBA? You have it somewhere there written. TBA was equal to minus 45. Is that correct or not? Yes? And minus 420, correct? And plus 360. That is only the moment of TBA about point O. And then we can expand that. Since I did it last time, I don't have to do it. So you go I minus J plus K, and the end result ends up to be equal to 2,520 I. Again, 0J, because we never had 0. Neither of them has any moment about J. And plus 315 K Newton meter. This is MO as a vector. Again, it has only two components. The third component of the Y component is 0. And then you calculate the magnitude of MO. This is what I hear somebody says to use FD, which is perfectly okay. That's what you are going to do. So you find the magnitude of this one, which is 2,520 square plus 315 square, which gives us a 2,540 Newton meter. This is vector format. This is its magnitude. Now we know that M as a magnitude is equal to what? Equal to F times D. Is that correct or not? Or then we use D equal to magnitude of M, which is 2,540 Newton meter. What was the TBA equal to? Do you recall? TBA was 555. So divided by 555 Newton. Obviously, the answer will be this length from here in a space perpendicular distance, and that become 4.58 meter. And that's how things is measured in space. You don't go to space measure things. So if you want one airplane wants to go to one spot to another spot, and everyone wants to go to shortest distance, he has to get that route, so you know exactly the computer calculate all the data, etc. Yes.
Can you explain again why the position vector is from O to B?
That is the definition of that's the definition of A cross product B. I explained that before.
Yeah.
That was part of A cross product B, which started at point O, went toward the point of application.
Okay. So it's
Remember
from-
that? I have something to say about that. Just wait. This was the case. If this is the force, F, and point of application, let's change the number. Let's say the point of application is at C. Remember how I started the lecture class or two class before, and then I want to take the moment about point O. I said two methods. One method is F times shortest distance. If we don't have the shortest distance, I use this was R in that order. Look where we are taking moment about to the point of application. Where are we taking moment about? About point O. Where is the point of application is? B. Did you see that?
Yeah,
Yes?
yeah.
Okay. Now I have my second part come. This is what I told you so far. Yes or no? Now I want every one of you to do something else. Remember the moment of this force about point O end up to be this. Yes or no? Correct? Now I want you to do independent of that. I use this position vector and that one. Yes or no? Now everybody please write it down. I'm asking you to do it. Now write position vector OA, which is ROA. Remember that distances I gave you to that. This distance, I believe it was, the picture I gave you, the picture is in your, that distance is 7.75 meter going that way, and this distance was 6 meter, yes or no, correct? So having this as 0.75 meter, and this distance on the z-axis equal to c. So I want you to calculate it. I'm going to erase this 4. Notice, as you asked, I use the red position vector and the one that I already explained to you. That is that. Now I'm changing that. So please do that. So everybody, calculate this cross product. Calculate, I put it in blue. ROA cross product of TBA. Just change the R. See what happens. What's the result? I know what the result is. I want you to calculate. Are you calculating it with your calculator? Yeah. No. Do it by hand. You need to do that to learn it. If you did, you are not supposed to bring your graphical calculator to the quiz to be in the same level with the other students. So if you are doing that and you are putting right answer in front of you, I usually do not accept. Notice always in my quiz I say show me the detail of what you are doing. Detail means step-by-step process. So that one is equal to, let's put it this way, equal to I, J, and K, right? Force is the same, minus 45 was it? And minus 45, minus 420, and 360. But the position vector changed totally from the red to the blue one. Yes or no? What's the position vector? What's the x of that?
Negative 0.5.
Negative 0.5, correct? 0.75. Yes? And the y is what?
0.
0 because we are on the horizontal plane, and the z is 6. So in other words, do this expansion. What do you get? You will be surprised. What did you get if you do it correctly? Do it with your calculator, that's okay. Because we want to be fast now.
You get about the same distance, right?
What?
You get about the same distance?
I didn't ask you to calculate the distance. I calculated this cross product.
Yeah.
Because you see what he asked me, I don't remember your name. You asked me what position vector I use. I said you use the position vector from point O to the point of application. For us, that was B. Is that correct or not? That was the definition of the moment. Now suddenly I'm asking you to do something else, which is not the moment. But did you come up with the same answer? Yes or no?
Yes, actually,
No, it should be
Negative.
exactly the same.
negative Z.
Yeah, it's the same.
So if you get negative, means you made mistake in your expansion. Do it again. So anyhow, the answer is, if you do it correctly, the answer is, I don't have to look there, I don't have to expand it. If you do it correctly, exactly the same answer as before. What does it mean? What does it mean? That position vector you just asked me a minute ago, it's not unique. I can use any other position as well. So in other words, this is the story. If this is point C, so far I always said to use this. Is that correct for you? Not because usually O is given, C is given. Is that correct or not?
Yeah.
However, if there is another point, this is the idea that I presented to you. If I use, this is point A, and I use, instead of that one, I use ROA cross product F, still I get the same amount of moment, as shown here. Everybody understand that? Look, the cross product of this position vector and this position vector and that force end up exactly the same. Is that correct or not? Yes? Therefore, write it down in your note. That's the modification to what I said earlier. Earlier I said, oh, always use that one, which many times we do that because coordinate of C is given, coordinate of O is given. However, if maybe in some problem, if this coordinate is easier than that coordinate, either end of the cable or at the middle of the cable doesn't make any difference. By the way, what we are saying as a theory, I can prove it in a minute, that this or that or that or that, all of them gives you the moment. Doesn't doesn't make any difference. As long as it start at point O and end anywhere on the line of F, anywhere, doesn't matter to be point of application. Is that right? Of course, it is silly to go to this point which is nowhere, or usually you have the beginning of the vector and the end of the vector. Everybody understand what I'm saying? That all of them, this is the proof of it. Both of them end up exactly the same. Now, what happened here is this. This is the proof if you want to. So let's go back to the theory. It's not required, but I'm going to tell you because probably you are surprised what happened. Here is this. Originally, this was idea that I mentioned. This is point C, this is point O, and we said ROC cross product of F. Yes or no? That's the moment. So far, that's what we knew up to a minute ago. Yes or no? Correct? Then suddenly I said, let's change that from C to point, where was it at? A. Is that correct or not? I gave you another position vector. So suddenly I said ROA. So we know this. We know M from the past. Moment of this force about this point O, according to the original explanation, equal to ROC cross product of F. Is that correct or not? Yes? That's the moment. That's the definition of the moment. Start from point O and at point of application. Yes or no? Now what we are saying is that ROA cross product of F should be equal to MO. Yes or no? Now let's say what? This is the question we want to get. Equal to what? That's the question. Notice in this triangle, I can write ROA plus RAC, ROA plus RAC equal to, remember the rule of triangle? Yes? Toe, head, this plus that, lecture 1. This plus that equal to that. Is that correct or not? Triangle rule, correct? Adding two vectors together. That's why really we study that. Every time we add two vectors together, we use component. But at the first lecture, I asked you to do the adding the vector by using a sine rule, cosine rule, or triangle rule. Is that right? That's a triangle, yes? Notice, in triangle rule, position vector OA plus AC, toe head, must be, this is the resultant of those two. Is that correct? Or equal to R OC. That's obvious to us. So ROA plus RAC equal to what? R OC. So therefore, if I put ROC equal to that, that becomes equal to ROA cross product of F plus RAC cross product F. What I did, I took that ROC, put both of them together and expanded. Is that correct or not? Yes? But notice, this is what we have there. But look at that. What's this value? RAC cross product of F. They are all the same line. Therefore, cosine theta equal to, sine theta equal to 0. So that magnitude must be equal to 0. So if that's equal to 0, notice both of them giving the same. And that's what you just did it by number. That's it. That's the proof of it, theory-wise. Is that correct or not? Yes? Because the other term doesn't have any moment. RAC cross product of F, they are on the same line. By definition, it's magnitude of first one, magnitude of second one, times what? Time sine of angle between the two, sine of 0 is 0, therefore it's 0. Is that correct or not? Yes?
How did you get 2,500?
Now, hold on. Let's get to this. Did you understand that?
Yeah.
So in other words, I can use ROC, ROA, or RA prime, whatever, correct? Now coming to here, what was the question? The expansion of this?
Yeah, how did you get 2,520?
That 6 minus 6 times 420. 2,400 plus 120, 2,520.
Okay,
Agreed?
yeah.
Okay. Then minus j, then this time that become 270, minus 270 becomes 0, then k, this time that was 3. That's the example. If you make a mistake there, okay. Is that correct or not? Now notice so many different aspects of this being covered. Now you know what we were talking about. I'm glad you asked that question actually. Is that correct or not? Yes? So use any part of a line of application, it will do it for you. Yes. Still stick to the first one because that's the simplest of all. Because usually the point of application, the coordinate is given better than any other point. But you see a simpler point, for example, a line going through the point of also use that one. Everybody understand what I'm saying? That's it, right? So these are covered. Now we get to the last part of it. Again, one more time, I'm going to explain what I said last time. Moment about x, y, z axis. Please write it down. We are done here. So let's go back to the idea that I presented to you last time. One more time, review. I always do that because between Thursday when you have a quiz coming and Tuesday your mindset is a little bit different. Is that correct or not? In the quiz time you are worried about the quiz, you're probably not listening 100%. But Tuesday, you're better off. Is that correct or not? Yes?
Yeah.
All right, so what did I say about the moment about x, y, and z axis? So I said if there is, let's say, put it in perspective. So here it is. There is a force here, F, applied at point A, and somebody comes. This is the space. Notice this is here or there. Somebody come and ask you, find the moment of this force about the z-axis. Yes or no? How do we approach this? Now, there is a general method that a couple of you or few of you, probably more than that, because a couple of you, I saw it during the office hour, they said, what is all this thing that they are using in the solution manual? I have not seen it. I explained to them that I haven't explained it to you yet. So that's what so that's why you see those odd things there. Is that correct or not? But they are not odd. First, let's divide this. We are talking about moment about the line. Notice this is very simple. If the moment about the line, those lines become x, y, z axis that we know of. So let's put it like this way again. Moment about x, y, or one of them, z axis. And you want to answer that question, the answer you already have, because I already explained it through that tree to you. What should I do? Can I take the moment about point O?
Yeah.
Yeah, you see, moment of this force about point O is a vector, yes or no? And that vector has three components, x, y, and what is mx? Mx is the moment about the x-axis. What is the my? My is the projection of that vector over the y-axis. That's what I show you here. Previously, somebody asked me, what did I show you here? I said, okay, this is a vector. Let's assume this vector MO. This is MO, yes or no? Or cross product of F become MO, which is perpendicular to the plane of R and F in a space. It's going somewhere. Is that correct or not? Let's say this is this plane. This is R, this is F. Moment is here, somewhere in a space. Is that correct or not? But this moment, which is at point O, has three components. We can break that as we did before, finding mx, my, and mz. That is why when we wrote this, please pay attention what I'm saying, that when you write mo equal to r here, OA, cross product of F, didn't we end up with three components, x component, y component, those are the moments about x-axis, y-axis, and it could be plus or it would be minus. Then I said this, okay, if this ends up to be equal to, remember, it becomes ijk, so it ends up to be a number times I, is that correct or not? Plus a number times j, as you see it here. Number I, number j, number k, is that correct or not? Yes? And then plus mzk. What are these mx, my, mz? Those are projection of this moment over x-axis, y-axis, z-axis. It's called a rotation about x-axis, y-axis, and z-axis. The only thing is, how do I determine the sign of it? That's what I showed last time. I said if the vector going, now I show the sign of that. Please write it down. If the mx is going this way, that means put your hand there. Is it plus or minus? This is plus, this is minus. This is plus, this is minus. This is plus that. That's what I showed last time. I said, okay, this is plus, mx plus, and this is plus, and this is my, and this is going that way, mx. And this is positive, positive, positive. So if this ends up 0, then I don't have any moment about the x-axis. Now, if somebody asks me, do the moment about this force, about z-axis, I go through this operation, yes or no? Then I get all three of them, then I say, I don't want this, I don't want, I only want mz. That's the moment about the z-axis, as simple as that. Don't use any other method. Any other method that they are using in the book is a general method and does not apply here, everybody. This is the simplest method you've got. The other method is correct too, but when I explain to you, you will prefer this one, I promise you. Is that correct or not? You will see in a method. The other method is very complicated. Not very complicated. The students think they are complicated. It's not really. However, it's different from this. Everybody understand what I'm saying? Yes? Now, somebody comes and asks you to find a moment about z prime axis. Then what should I do? I explained also that one last time. I don't know whether you grabbed it or not. What do you do? That's not z. But can I take the moment of that force F about point O prime and put for myself a set of axes x prime, y prime, and z prime there? Yes or no?
Yeah.
So the vector goes there and has three components there. So if the axis is here, and the question is find the moment of this F about z prime axis, I take instead of moment about O, I take the moment about O prime. So in other words, this was question 1. We wanted this, I have it. Actually, I have 2 bonus points. If somebody asks me what's the moment about X, I have that one, and I have a moment about the Y. Everybody understands, by taking moment about point O, correct? Now coming to the z prime axis, all I have to do, because x, y, z is arbitrary, isn't it? I can put my x, y, z at point O prime. Everybody understand that? That's the same technique. So everybody at this time of this game after 4 or 5 weeks static, everybody knows x, y, z is arbitrary. I can shift it anywhere I want to. Is that correct or not? In other words, shift your x, y, z axis to here. Take the moment of that one about this point. Is that correct or not? Which is R cross product of F.
So this time, MO prime, question number 2, is equal to R O prime A, this vector, cross product of F. But that one also gives me MX, MY, and MC. But this one would not be MX, it would be MX prime, M1 prime, and MZ prime. Let me write it down. I did that with it. So this becomes MX prime I plus MY prime J plus MZ prime K. So that is the technique we are going to use there. Correct? And you have a couple of them in your homework. I don't know how they set up. Sometimes they have this, there is a board going like that. There are hinges here. They put a force here and they take the moment about the z-axis. Yes or no? Have you seen that homework? Take the moment about point O, find MX, MY, and MZ, throw the other two out and say that's MZ. Is that correct or not? Yes? Good. Now we come to the last part. What do I do if the force is here and the line is there, which has nothing to do with the X and Y and Z? That's the discussion we want to have today. So please write it down. So this was the moment about X, Y, or Z axis, or X prime, Y prime, Z prime. That's the same thing. Is that correct or not? Yes? Now in general rule. Now here we go. This is also mathematically simple, but you have to put 2 and 2 together. Please pay attention to what I'm doing in definition. Here, finding the moment. This is general equation. Okay. Here is the force. F applied at point C, so point of application is C. And I want to calculate the moment of that force about line L. This is the question we want to answer. Has nothing to do with X and Y. The force here, line is there. Is that correct or not? How do we do it? In order to achieve that, before we go that, I need to go back to the dot product and give you another application of dot product. One application of dot product, I already talked about it, was A dot product B divided by A magnitude and finding the cosine of an angle between two lines. This is the same thing, but let's put it in a different format. Okay, so now first, let's do that. This is something to do, write it down in your note, application of dot product. And this is the following. Let's say I have here a line L, and I have here a vector, any vector U. Doesn't have to be F or M or whatever. General vector U. And I want to find the projection of the U over the L. This is the idea. In other words, I want to draw a line here. This angle is 90 degrees, and I want to find the projection of a force over a line. By the way, mathematically, what I'm telling you today, this is perhaps the most difficult part of the entire book as far as the math goes. And it is really the way I explained to you, it should be very simple. So we are looking for this line, is that correct? Which we call it UL. What is UL means? Projection of the U over line L. Is that correct or not? But everybody knows the answer. If you have this angle theta, if you have the angle theta, if theta is given, listen, theta, write it down, is given, this is what you do. UL magnitude equal to what? Equal to U times cosine of theta. We have that in lecture 1 and not even here in this class. You have it in all the math classes. Yes or no? Correct? Now, if theta is not given, what should I do? Let's say that for whatever reason, theta not given. Everybody agrees that is the projection of this force over line L, yes or no? However, how do you define a line? 2 point or lambda, yes or no? So when we say a line is given, in effect, you can see 2 point here and here gives you lambda L. So let's assume the lambda of the line is given. Correct? Okay, one more time.
This is the magnitude of U. Where's the direction of UL? What's the direction of UL? The direction of the UL is along the L, which is lambda L. Is that correct? This is its magnitude, so this is the magnitude. Let's find the vector format. Vector UL is equal to U cosine theta, theta, yes, multiplied by lambda L. Is that correct or not? This is the magnitude, that's the direction, correct? Because it is on the line. Yes? Okay. All of this we already know. Now, theta is not given. I'm looking for U cosine theta. Can I use this? Lambda L dot product of U. Is this the dot product? Yes? What's the dot product of A and B by definition? Magnitude of the first one, magnitude of the second one, times what? Angle between A to B, yes or no? What's the magnitude of lambda L? What's the magnitude of unit vector is? 1. I'm glad. Okay. What's the magnitude of second one? U is U. What's the angle between going from here to that? That's cosine of theta. Is that the same? Yes? Yes? That's how we find the theta in other problem. Remember, I use the same format. Yes or no? Everybody see that? Lambda L dot U is exactly this. Correct? Agree? Therefore, UL equal to, instead of that, if theta is not given, here theta is given, I use it. Theta is not given, instead of theta, what I'm using? I'm using a dot product which end up exactly the same. Everybody see this quantity and this quantity are exactly the same. In other words, magnitude of that is lambda L times dot product of U. So therefore UL becomes lambda L dot product of U. That is its magnitude and its direction is that. This is the magnitude, that's the direction. Yes? So in other words, we eliminated theta from the format by using a dot product, which I used it earlier. You all agree that's the way you want to use it. Is that correct? Now coming to this one. Having this in mind said that how we calculate the projection of the vector over a line, let's go there, find out what's the moment of this force about this line L, which will be defined by lambda L. Is that correct or not? Yes? Correct? Now, to do that, this is what we are going to do. There is a proof of it. Again, I am going to skip the proof. If I have time later on, I'm going to mention that. But otherwise, it's not necessary. The moment of F about this line is the following. First, I pick up an arbitrary point, any point. On that I put A there. A means any point on the line. Can I take the moment of F about point A? Can I do that? Everybody can do that. I already explained that several times. To find the moment of F about point A, we are going to use this cross product. Yes or no? So please write it down. MA. I put it in red because the result is in red. MA equal to R AC cross product of F. This is what you asked me earlier, and that was the answer, the first answer. Is that correct or not? But that's not the moment about the line. That's the moment about the point A. If I want to calculate, which become a vector. So this moment, now I should have used this different color. So let's call it in green. So MA is green now. Make it, change it to green. MA. This is red, this is green. Is that correct? That's a cross product, red and black gives me this vector MA. Is that correct or not? Yes? Which is the moment about point A. But if I project that over the line, I draw here a line down. This is what I'm looking for. That is ML. This is moment of that projection of that moment M over the line gives me a rotation about the line. If it goes this way, I call it this way. It may go like that, which this blue line, it goes like that. Therefore, this force causes this line either rotate this way or rotate that way. Everybody understand? This is in general. So what should I do here? Notice I know the rule of projection. Remember that this u now, instead of u, suddenly what do I have? Instead of u, I have MA. So I have to put MA there. Is that correct or not? Therefore, write it down. ML, which is in blue. So ML, which is projection of this one over the line L. I have it here. For this, change it to MA, and this is ML. Everybody understand? Just change the U to M. That's it. That's what you do. Is that correct or not? Therefore, become equal to lambda L dot product of MA being any point here. We can again prove that any point will do it. Doesn't have to be very specific point, which is its magnitude. Dot product of two vectors is a magnitude, and then if I wanted as it as a vector, I have once again to multiply it by lambda L, because this was its magnitude, that is its direction. In many cases, you need only the magnitude, you don't need to find that. Is that correct? So they ask you how much moment you have. Now, you can use this one about line X. So what happened? Lambda L become what? I, and A become point O. Is that correct or not? That is what I was doing before you realizing it. I use, this is the definition of moment one more time. Finding the moment of F about this line is this. First you pick up a line on a point on the line. Take the moment of F about that point, which is this green vector. Then projected it by that law over the line, and that's your moment. Is that correct or not? That's exactly what I did without you realizing. This is what I said. I said, this is the force. No, you don't have to write this. This is in your notes. Take the moment of that about the z-axis. Yes or no? What's my point? My point should be O. Because O, not even it is on the z-axis, it is on the x-axis and then y. Then I take that, then I project that force moment that comes here, I project it over there. Is that correct? And that's exactly what we do without you realizing. Who cares this? I already for x and y, z, I don't need to call I do all of that. I take the moment about O, I find moment about x-axis, y-axis, and z-axis, because that's the projection of that moment. So, however, if it is in general, then I use this method, which is the following. Please write this example in your. This is an example. The general example, I believe I have given you only one example because you have not too much, I mean, doesn't have that much application, but the moment about x, y, z axis is what you need in future a lot. Everybody understand that? So let's put it that way. So let's go to a general method. Let me see whether I have here a problem that we can help you out. All right, here it is. Actually, it's good. So here we go. This is an example, guys. So put your x, y, z there. X, y, z. And let's say that we have a line here. This is our line. Between point A, coordinate of A is 2, 2, 4. And coordinate of B is given 6, 5, 4. These are all in meter. This is our line. And there is a force here. You can draw it any way you want. This is force F, and point of application of that is C, and C is 8, 4, and 5 meter. F vector is given of, I just made it very simple, 10I plus 20J plus, as you notice, I'm sitting in my room and I'm making up this problem for you guys. Is that correct or not? 10, 20, and 30, doesn't matter. Yes? But it is the idea is important. That's, of course, is in Newton. So we have a vector here in a space at 10 Newton x component, 20 y, and 30 there, which is coming here positively, yes or no? And we want to calculate the moment of that about line AB. I'm sorry, that is AB. And using the idea there. Is that correct or not? What did I ask you to do first? First, what do you need? Obviously, we need lambda L. Do we know how to calculate lambda L? So let's do it. Lambda L, already I noticed a couple of you were indicating how to calculate lambda. Taking the 2 points, yes? Subtracting, equal to RAB divided by its magnitude. So first of all, we are going that way. So this way is positive, AB is positive, BA is negative. So we're going that way. Equal to RAB. How many times have you that? Divided by its magnitude. Many, many times you have done that. There should be no problem there. Coordinate of B minus coordinate of A. What's coordinate of B? 6 minus 2 is 5 minus 2. 4 minus 4 divided by. This is not by accident. That doesn't happen like that. It just, I gave you a 3, 4, 5 slope. Everybody understand that? Not even that. AB is in the plane of XY. Is that everybody see that? Because that doesn't have any C. Is that correct? So really, if you want to draw that, you have 4 run and 3 rise, and it is in the plane of that. I'm just playing with you guys. Is that correct? Is that correct or not? Yes? But doesn't have to be there. It could be a space. Correct or not? But that is lambda of L, which is 0.8 by 0.6. Remember that? You don't need tangent and everything. 4/5 and 3/5 and 0. Correct? Everybody. So that's our lambda. So anyhow, lambda L, you want to break it that into decimal point, that's 0.6i, oops, sorry, 0.8i plus 0.6j plus 0k, no unit because it's meter over meter, that's right, because those are cosine. All right. Now, the second point is, I want to take the moment of point F about this line AB. Where should I should take a point on the line. Which point should I take? Either A or B. Let's take A, which is simple. So all I'm saying that find this moment, ROC, cross product of F. Yes? Now, by the way, this at the end, this part, is that we call it a triple product. You know why? This is lambda L. This is R cross product of F. So let's write it down. MA equal to R, which R? R AC, are you everybody with me? Cross product of F. Is that correct or not? Yes?
Yeah.
Of course, then this becomes a vector here. So let's go again at the same color I use here. That is a green vector there, just to match the both together. So that is MA. Is that correct or not? Yes? But that's it. I don't want that. I want to project that over the line AB to get the blue one. Is that correct or not? Yes? So if I want to calculate this one, everybody understand that? That is ML. And then FL equal lambda L dot product of MA. But MA itself is what? RAC cross product of F. Yes? Correct? MA, the green one, is R cross product of F. Correct? And then multiplied by lambda L. This is its magnitude. That is its direction. That magnitude is a triple product. You are familiar with the triple product? I gave you in the handout. You know how the triple product works. This time it's not IJK. It is the following. This means R, look what is happened here. R cross product of F, it's another vector M, yes or no? L lambda dot product of M is a scalar, you know that. Everything, so it is a triple product, but the result is a number. Is that correct or is not a vector? Multiplied by lambda, then it becomes. For our problem, this is the case. For our problem, you can do this individually. First calculate that one and then put it here, or you can do it at one bunch. I'm doing it one bunch because we call it triple product. So ML, magnitude, which is all of that. One more time. Lambda L dot product of RAC cross product of F become equal to, please write it down. Now here is lambda X, lambda Y, and lambda, let me write it first. Lambda X, lambda Y, lambda Z. Then I have Rx, Ry, and Rz. Then I have Fx, Fy, and Fz. As you see, there is no ijk, so therefore it is a scalar number. Yes or no? Correct? Now for our problem, this ends up to be equal to, what is our lambda x? Lambda x is, what's our lambda x? Lambda x is 0.8. What is the lambda what? 0.6. What's lambda z? 0. What is r? Here we had ROC. Oops. RAC. Okay. RAC. Oh, this should be. RAC. Is that correct or not? Yes? This is not O, that's A. RAC, which is coordinate of A minus coordinate of A, which is 8 minus 2 is coordinate of C minus coordinate of A. Is that correct or not? Yes? What did I say? I said B. No, okay. Coordinate of C minus coordinate of A. 8 minus 2, which is 6. Correct. And then second one, 4 minus 2 is 2. And finally, 5 minus 4, which is 1. And then finally we come to the force itself. What's the force? 10, 20, and 10. This is just for example to show you 20, 10. And then you expand this, as you see, this is, I do the expansion. This is 0.8 multiplied, I hope that you can see from that point, 0.8, 2 times 30, which is 60, minus 1 times 20, minus 20. Is that correct or not? Yes? And then become minus 0.6, remember, plus, minus, plus. So you cross that, 6 times 30, which is 180, minus 1 times 20, minus 10, and finally plus 0, which is 0, doesn't care. Is that correct or not? Yes, doesn't care. You calculate that number. That number is your magnitude of ML. This is magnitude of ML. ML ends up to be, when you calculate that, this become 40 times 0.32. That's 170.6. You just multiply that together. The magnitude ends up to minus 70. Is that correct or not? Yes? Yes?
Yeah.
Okay, minus 70. And that is Newton meter. It means this line is not going to go this way, it's going to go that way. This is positive direction, this is going that. It's going, this force causes this line to rotate about its own axle, this is the axle, but not positively. Remember, AB is positive, it came negative, it means it should be it's going like that. That's the direction of the moment. The magnitude of that is minus 70. What's the vector part of it? ML equal to ML as a vector become what? Minus 70 times, again, lambda L, because it is on the line. Is that correct or not? Yes? So you can answer both the magnitude and the either way. Sometimes, most of the time, you are going to ask you about magnitude of it, because the vector part of it is simple. You just need to see what happens. However, give me one more minute, extra minute. Now, remember earlier I said how to calculate the moment about a line? We could use that. Actually, go home, check this one. If this line happened to be z-axis, what happened to this? What is the lambda of z-axis? mz become equal to, what's the lambda of the z-axis? Is, what's the unit vector along the z-axis? Is k. Very good. So k dot product of MO, because O is on the z-axis. Yes or no? Then k. This is what you are using in the solution manual. I asked you not to use it. Is that correct? For the O, you don't need to use this technique. You only use this technique when the line is in a space and the force in a space has nothing to do with the x, y, and z. Anytime it's x, y, z, use the old procedure. Everybody understand that? Because if you check this, remember, because this is the dot product, you will see what happened here. This happened to be, I'm only using the magnitude, this is the magnitude. It becomes 0, 0, and 1, notice everything becomes 0 except the k direction. I already have the k. Everybody understand what I'm saying? This becomes equal to rx, ry, rz, then fx, fy, fz. Notice 0, 0, you only get 1 times that. Is that correct? And that is the moment about the z-axis anyway. So who cares about this method? As I said, a couple of you asked that. Everybody understands that. Again, this method, only one problem or two. I don't know how many times I asked you. And if it comes in the quiz, I'll give you the equation. Don't worry, you don't have to remember it, write it here or there. So please do not that. That's not a question of memorizing. It's a question of using it. That's why. Okay, see you. Yeah, yes.